My name is Kyle Groves. I am here with ATG as a senior technical specialist. Today we are here to talk about how we can just design a little bit smarter with our roadway modeling. Now, this is a loosely defined series that I've decided to put together, the first part of which would have been back in October of 2019, but in it we discussed alignments, offset alignments and offset profiles. If you missed that, I'll be sure to point you toward the ATG YouTube website where you can pull that down. We will also do a brief review of that just in case you missed it. We're going to talk some more about the connected alignment feature inside Civil 3D. So, and the reason why is because the intersection object is more of a magic button, really, than anything else. And before we let the magic button do all the work for us, it's very important to me that the folks that I work with and the folks that I teach understand the fundamentals of how those work before we go into the process of just trusting the magic button for its outputs. And with that, let's go ahead and get started here. So we're here today to talk about connected alignments and just alignments and profiles in general, because alignments and profiles are really well functioning, both baselines for our corridor models. That's what our assemblies attach to. That's the 3D path that our typical cross-section follows, as well as target objects. So even if we're not using this as a starting point for our design, they give us really fine-tuned control over all of the different ways that we can modify that typical cross-section that is defined by our subassembly. So we can be narrower or wider, we can be steeper or shallower for any one of these model elements that we want to use that targeting for. So that's why it's important for us to talk about the different types of alignments and how to work with them before we go into the actual construction of an intersection with a corridor, which will be that third part, date TBD. So what we're going to talk about today, we're going to go over a brief review. What types of alignments are there in Civil 3D? Over time, our Home tab and our Create Ground Data panel has gotten bigger and bigger, and now you're going to see a whole mess of different ways that you can create alignments in Civil 3D. So we'll go over kind of my category for how those are defined, a little bit different than what the interface shows you. Next, we're going to talk specifically about our topic today, connected alignments, and what makes those so unique and so powerful for this problem of designing an intersection in a corridor. And then we'll get into the software and we'll go and start working with those connected alignments at our intersections. So a couple of different ways that the software wants you to think about the different alignment and profile types available. So here in my screenshot, we can see that we've got the drop-down menu from creating alignment. So we've got our alignment creation tools, we have our offset alignments, and we have our connected alignments. But then if we actually get into the alignment creation dialog box, we'll notice that Civil 3D has kind of a different way that it likes to categorize these. So we have different alignment types of centerline, offset, curb return, rail, and miscellaneous. Really what these boil down to is that the center line and the rail alignments, these function identically in the sense that if you apply a design speed, there are pre-baked curve radius tables that you can reference. You can build your own, you can use basic AASHTO ones that come in with the software, but that's how those work. An offset alignment is typically going to be a dependent object data, so it's going to have that dynamic reference with either another center line or a rail alignment. And yes, you can offset. You can create offset alignments whose parents are an offset alignment. So that works too. And then today, what we're talking about with the connected alignments is more of what's going on with these curb returns. So you could manually define this, but this is a space that's typically reserved for that connected alignment type that we're so interested in today. But with all of that, I'm going to just go ahead and propose that that's not really how I like to think about alignments in Civil 3D. When I think of these, I think of having manual, dynamic offset alignments, or dynamic connected alignments. So what I mean with a manual alignment is whether you're creating this from pipe or pressure network parts or whatever else, it's going to help you get that line, or from object, it's going to help you get that line work into your drawing. But at the end of the day, you still have full control over placing and editing points of intersections, tangent line segments, and curve segments. You can use these and create them from an existing geometry, but overall, this is going to be independent data. And I'm also lumping in profile, unless otherwise stated, with the term alignment today, because we're used to using those in pair. So, we need to do that manual design. We need to cut our surface profile. We need to come up with logical curve data and slope data for our profiles and get through all of that. But once we have that key design information done, usually a center line, but not always, then we can now start thinking about our offsets. And these are going to be dynamic. And so with this, you're going to follow another alignment. And the benefit is that you're going to have intelligent offset and curve interaction. So when I'm 12 feet away and I'm on an inside corner, my radius of that corner will automatically be 12 feet shorter than the center line or than the parent object. And that exterior corner is going to have that 12-foot radius added in on top of that. If my parent object changes, so too does my offset object. So it's going to track all of that geometry for us. For our offset profiles, the really cool thing with this is we get to specify that cross slope to be vertically offset from that parent alignment. So it doesn't matter how far away I am, I'm able to say I will always be minus 2%, minus 5% from my parent profile, and then my horizontal is going to tell me where my elevation is to solve that right triangle. And then this is dependent data. So if our manual object is independent, our dynamic offsets and our dynamic connecteds are going to be related and dependent upon that manual. And as I mentioned before, you can offset and offset. So these data can be 1 or 2 or 3 degrees away from that parent object if we so choose. Another really great thing about these offset alignments in profiles is that you get to add in a widening. This is really useful for doing turn lanes as you're approaching an intersection, or doing some on-street parking, whether it's 45 degrees or parallel or whatever. We can widen that road and still use only one region in our corridor. Now, for our connected alignments, let's go ahead and talk about some of those. So this is a dependent piece of data, which means we have those dynamic connections with the rest of our model. So we update the parent. That's going to update our offset alignment automatically, which is going to update our connected alignment automatically. What is also really cool about these is it overlaps with our input alignment and profiles. So as we can see here on this screenshot, this is midway through creating a connected alignment, but I chose this western offset of my north-south alignment first. We're going to increase direction going this way, and I chose the southern offset of my east-west road as the other one, and then my direction is just going to be, that's the quadrant that I'm in. But where we overlap, we don't have to do any guesswork to determine our distance in front of or behind our point of curvature and our point of tangency when we're working on these. We get to define where that overlap is going to occur. We can do so graphically with snaps inside Civil 3D, or we can be very deliberate and do a tabular edit through the offset alignment or through the connected alignment properties dialog. And there are some cases, we're not going to see it today because we're not going to actually build the corridor today, but there are some cases where it can be beneficial to have a really large overlap. Maybe it's 50 feet, maybe it's 100 feet. But that overlap and that dynamic relationship is critical to how much these objects can help us in the software. It is important to note, however, that our connected alignments only function as curves right now. And unless 2021 has changed that, we'll be working in 2020 today. That's how that is. So one thing did come across this while helping a client develop some workflows, but if you're using corridors in aviation workflows and you're using those FAA, those straight line chords and tangents to design the edge of your pavement, it's going to be difficult to use corridors in there because you're going to run into some weird bow tie situations. So that's part of why the connected alignment, or at least from the best I can tell, functions as a curve, because when you have curves, your corridors have a much easier time resolving those bow ties where your target extensions overlap. And the last part, we've talked about how cool it is that these can overlap with our alignments as we're transferring ourselves from one to another. But in this area where we're not connected, where we're not overlapping, we do get independent profile design between our point of curvature and our point of tangency. So this is really great because it allows us to do two things, at least primarily, and there are more, but this helps us make sure that we can have a good ADA access if we are designing some sort of a curb ramp through our sidewalk and this intersection. And it also lets us define whether or not our stormwater in this corner of our intersection is going to collect or reject water. So we can now have a profile view to do our stormwater design, and one more thing that we get to connect to the rest of our model. And then here's what that looks like in Civil 3D. So what we're seeing on the left here, this diamond grip, that is my overlap point with my first alignment. This diamond grip is the overlap point with my second alignment. And then I just threw in some random PVIs in order to show that we get that independent profile design where we have that independent section. So let's go over a couple of tips before we get into the software with using our connected alignments at intersections. These are going to represent curb returns as corridor baselines for this workflow. And one of the reasons why, if you were at my last webinar a week or two ago where we talked about link to mark point functionality, we did go over the fact that corridors build at one particular station at least perpendicular to and away from our baseline. So you know, if we're shooting at something that's round, or if we're dealing with these on-street parking bump outs, your curb can look really funny depending on the perpendicular relationship of your baseline and your target object. So because we want these curbs to look right and have accurate widths and such, we're going to use these as a baseline in our corridor for those curb returns. And it's going to provide us a new attachment point for our assembly when we're going through that. When we're using these connected alignments for our intersections, you're going to have to use some kind of a naming convention. I'll propose one, but the number of objects that are going to be used by your corridor as both input and targeting data they're very, very high. So keeping this all straight comes back to one of my core tenets that I talk about a lot with Civil 3D modeling, which is be deliberate and use the name of your objects to your advantage. So because this is going into an intersection, I like to put in a string value of my just int. We're going to call out what alignment is our primary, what alignment is our secondary, and then we're also going to identify the corner or the quadrant of that alignment. So for example, today, we'll have 4 different connected alignments, all with Primero Pass and Segundo Street, and then northwest, northeast, so on and so forth for those quadrants. This is going to make it so that I don't have to escape out of a 5 deep dialog box train in order to go back and reference my prospector tab, in order to go back and see something in my properties palette. Because I named it right, I can very easily identify it in a list of its peers. Another thing, this probably won't make sense until you tune in for the next iteration of this series, but your stationing should increase in the same rotational direction. So counterclockwise or clockwise, doesn't really matter which, but when you do this, that unlocks an ability to cut down on the number of assemblies that you're using for your corridor modeling. So it allows us to keep our drawings much leaner from a data and an understanding perspective. I mentioned before that we do have that dynamic overlap for the alignments that we are connected to, and having that overlap be larger can benefit us a lot during our intersection design, especially when we have intersections that aren't perfectly at 90 degrees, or if we have different curb return for our radii. Again, this comes down to being lean with the number of regions and definitions that we have to have in our drawing. If it doesn't make sense today, that's fine. I'll show that off in the next webinar for this. When you're determining that overlap, you do have a graphical way to do that in the software with grips, as well as through your alignment properties. You can go into the new connection parameters tab and type in what you want that overlap to be, or what you want your curve radius to be. Let's go ahead and get inside the software and see how some of this is going to shake out. So here we are inside our drawing. Last time we were looking at this, we're looking at offset alignments and profiles, and now we can see that I do in fact have my intersection over here. Right now it's set up as a 4-way. Can easily talk about this as a 3-way as well. And what I have here are just my parent alignments. Primero Pass is running east to west. Sorry, west to east with increasing stationing to the east. Segundo Street is running north and south with increasing stationing to the south. Now remember, that does matter because anything with a positive offset will be to the right of our alignment. Anything with a negative offset will be to the left in the direction of increasing stationing. So I've got a few things pre-baked in here, but I'm gonna go ahead and kind of just talk about this problem. You know, how are we gonna go through and connect my eastbound travel lane with my southbound travel lane? How am I gonna design a curb return that's going to pick up on that dynamic data? Well, I suppose I could, either draw a polyline or or just go right into creating an alignment with some PIs and some PVIs, but that's going to get pretty interesting pretty quickly because we'll notice that we don't have a lot of control over our overlap in our stationing and so on and so forth. So just grab this polyline. Fill it with a radius of 35. And then let's just say I want a 30-foot connection overlap with all of this. So I've got 30 foot of parallel tangents covering over those, and then 35, whatever that circumference is, for my actual curve location. Right, now I gotta come in here and I have to choose a direction for my alignment from object, but that's still not going to get me any of my dynamic profile stuff. And I do want to go through this process, so thank you for bearing with me, but I do want to go through this process because there are some cool things that you can use in other parts of your design. So we're going to get this alignment, we're going to get this surface profile cut, get a profile view going. So I have my existing surface profile, but I need to understand where my elevations are based on some other alignment and profile. Easiest way to get this done, in my opinion, is to use a COGO point. And you can create a COGO point based off of an alignment's station and offset. So I can start out, I'll go with my 0 station first, which is the north-south. I'm going to choose an alignment. I'm going to choose a profile because I already set this up with my offset profiles. This is going to be pretty straightforward. I need a station, I'll put that at 0, an offset of 0, and then a point description. I'm going to use 3 descriptions. One is a tie-in, we'll use that at the ends, and then, sorry, that was not correct for the stationing on that one. I should have been wherever the 0 of my connected one is. As we can see, doing this manually can get pretty curious pretty quick. Station is there, offset is there. All right, so that's one spot we can use. We can use another one for our kind of our divergence point where things are going to become unique. And this is PC for point of curvature. Now, in order to change alignments, I actually need to exit out of that command and change alignments. /profiles. This next one here is going to be the PT, or offset of 0 description PT. And then this last one here is going to be an offset of 0 and a description of pi. So now what I can do to kind of get some reference information from other parts of my design is I can take these COGO points and I can project them into a profile view. We'll see there are those first two, and I should have done that in one step, but I guess we'll do it in two. And now, theoretically, I could come in and I could draw in a profile and just recognize like, hey, here's my static part, and here's where I need to be doing my other stuff. But these COGO points, they don't tie in with my parent alignment. They don't tie in with the profile that they came from. So if my center line changes, or if my offset changes, I got to start all over. So what we're really going to be interested in doing here is one, flipping the stationing of this offset alignment, because my other one is the other way. Obviously, we would not want to do that in a real design situation. But what's cool is if we bring this over here, I've already got one of these connected alignments created. So I'll fast forward here in a little bit, but we'll overlap and just kind of prove this whole concept that we are just trying to get the same data, but in a smarter way. Move endpoint. Node. Now again, my stationing is a little off. This is using a 25-foot overlap. My manual one was using a 30-foot, but we can see that those points of connection are the same. So we've proven that a connected alignment can in fact get that done for us a little bit, or maybe even a lot of it faster. Let's actually go through the process now of creating some connected alignments for our the rest of our use. So there's really not that much that goes into this other than remembering some best practices. So alignment dropdown, create connected. What we're going to see is a prompt for our first alignment and our second alignment. Now, notice that earlier I said we need to have a consistent stationing direction, at least radially around this intersection. So I've already kind of defined that, and we are going clockwise, counterclockwise. No, regular clockwise. So if I want my stationing to be 0 and my end of my station to be higher in a clockwise direction, really what that means is I'm going to start with my first alignment being the north-south. My second alignment is going to be the east-west. And then the direction, this is just saying like where your curb return is going to go. So when I click to the outside, that means that this is going to connect in that correct way. So you're going to get a nice preview graphic of the directionality of your alignment. And now you have your creation dialog box. So step one, we need a naming convention. I really like INT, primary alignment, secondary alignment, and then what quadrant we're in. So this is going to be the northeast quadrant. Our curve radius, we can define this ahead of time. We can change it later. I'm going to go with 35 and 25. And then also do make sure, especially when you're checking your offset alignments and your offset profiles, when you get those created, make sure you go into this last tab about the profiles, and this button has to be checked. If you get to this point and that's grayed out for you and you are not able to create a connected profile, it means that one of your alignments that you're trying to connect to does not itself have a profile. And then you might have to back up and recreate your alignment, your offset A and P as well. So it's just going to ask you, confirm which profile you're trying to use. Always make sure you go through and do that. And then on the general tab, I do recommend having a visual style specifically for these curb returns. Mine today is just Same layer assignment, but I hard coded the color in because I didn't really like the one that was showing up. But have a specific one for your connecteds, have a specific style for your offsets as corridor targets. It's going to help keep things straight later on. And I don't usually recommend applying labels to your offsets or to your connecteds. However, I do, at least for a permanent basis, but you can get started by putting down your major and minor because that's going to indicate your directionality and it's going to confirm that for you. So I now have a connected alignment put together. Let's take a look at this in profile view. So I'm going to select my connected alignment, get my contextual ribbon, come up to the profile view, and simply accept my defaults to get that created. And again, we can see that I have kind of three sections here. Left and to this diamond grip, that represents my overlap. And notice how I chose a 25-foot overlap, and my minor grids are set up at a 25-foot spacing, so that jives, that makes sense. However long my curved section was, and then again, another overlap. To prove that I can come in here and start modifying things, I'm gonna select my profile. I'm gonna go to my geometry editor, and I'm going to come in here, and I don't need to create a new tangent or anything like that. I just need to be focused on inserting or deleting PVIs. So I'll come in here, and let's say I wanted to have a nice shallow cross slope for my ADA ramp that I'm trying to build in here. Come in at my labels so I can get my label set. Just select your alignment, right-click menu, edit labels, and then you can come in here and pull in any of your sets from your design drawing. And okay, that's a little steep on the front end. Maybe bring this up. 5% is too steep on the lower end. You can really just come in here and start doing things however you need to try and massage this so that things are going to work well. And now I'm around 5%, 2% cross slope, and 5% there. So like we could call that good for a curb ramp access. Additionally, we could kind of modify this a little more. Maybe I want to delete a segment out of here or a PVI out of here. And maybe I want to take this other PVI and it's going to be a low point so that I can have stormwater collection at this point, or it's going to be a high point and I'm going to have stormwater rejection over here. The point is, inside your independent area, you get independent control over your profile. And now we can go ahead and just kind of create the other two for these. So if I'm going to come into my alignments, create connected. So I need to continue my stationing to increase clockwise. That means I'm going to choose the south and then the east, pick that outside corner. Int primero, segundo, south, east quadrant. Another thing that's really convenient when you're putting these together, just clipboard copy that first part of your string with your intersection and your alignment callouts. Save just a few keystrokes. And then our last one, create connected. Again, my stationing always has to be increasing clockwise. So now we're going to choose the west and the south and the outside. Paste in all those. Southwest quad. And then I already had this one built, so I'll just delete it and recreate it. Had it set to a no display style, as well as being on a frozen layer. And we are going to choose the north and the west and the outside corner. northwest quad. So for this intersection with, it's going to be a four-way intersection. This is eventually going to be a proposed corridor connecting to another proposed corridor. And so, you know, we've got now all of the baseline and targeting objects we need for that corridor. And I can come through here, I can pop each one of these profiles into its own profile view. I can do all of that design that I need to use, and then eventually I could come through the process of creating my own corridors. Hold on, let me just go back and double check my PowerPoint. So with these, when I select my my connected alignment, I will see three different grips. I will see, two different grips, three total. In the middle, I have a round one that represents my radius for how big that is going to be. And then I have a simple diamond grip on each end, and that represents the end of my alignment where the overlap is going to stop. If I want to make this longer, I can simply drag it longer. If I want to make it shorter, I can bring it back to the point where it has, it's basically the PC and the PT are the point of curvature on the beginning of a curve, the point of tangency at the end of a curve. That is as short as I can make a connected alignment, because that is the instantaneous point where these two different alignments connect across their radius. But I do recommend having that data having some overlap. 10 feet, 25 feet, somewhere in that range is pretty typical for getting what you need done. However, if you have a very slanted intersection where you're looking at more like 60, 120 degrees, something in that range, you might need to increase this station overlap on your connected alignments even more if you're going to try and design an intersection the way I'm going to show you next time. If you want to get back and find tabular control over that information, simply select your connected alignment in Plan View, go into your Alignment Properties dialog, and you will now see a new Connection Parameters tab. And you can come in here and, you know, I had that set at 35. I misspoke. I'm so sorry. Scratch that. This will tell you what you have. If you want to be specific about your connection parameters, I would recommend draw yourself a circle, begin it or snap the center of your circle to your PC or your PT, and then simply type in your desired radius. So if I wanted to get back to 40 feet on each of these, I just type in a radius of 40. And now I can come and plop this down at that intersection point. And do the same from my PC, my point of curvature in this case. And now if we go back into our alignment properties, see that nice clean, I snapped off by a foot, but that nice clean value, really like the concept of just drawing a circle from your base point and extending your line work from there. So, you know, I said we weren't going to really get into the corridor stuff today, and practically speaking, the connected alignment tool is reasonably straightforward. You pick your two parent alignments, and you get independent profile control in the space between, and you follow both your profile and your alignment in the rest of the space. Now, I do have one or two more tricks I want to show you, but again, also for our corridor design, and you know, I could see some situations where you would want to build an offset alignment or a connected alignment where you're not doing a corridor model, but that's basically what these are here for, is to provide the power back to the user to create their own intersections with tools that were just really hard, really static to do before this connected alignment feature came out in version 2018. other thing that I want to show is just to kind of prove how dynamic these offset or these connected alignment objects can be, is I'm going to create a widening in one of these alignments, and we'll make it look a little silly, but again, just to prove how this can all go. So I'm going to choose the west side of my secondary roadway. We will not do a new alignment. We will begin at station 0, and I'll just pick some arbitrary stationing to the side. Right away, we can see that both of these alignments went ahead, these connected alignments went ahead and scooted themselves over to adjust for all of that. But what I really want to show off is what happens to this alignment right here. We can now see that it's following that widening as it's tapering back into its typical length. And if I change my offset parameters for this widening, what I can do is, I don't want to go curve line curve. Let's get really fancy and do curve reverse curve. We'll do 50. I'm not attempting to use rational values for road design. I'm just trying to find something that will make a striking visual. And as this widening gets further and further along, sorry, my computer's running a little slowly today. Come over here, unlock that grip. What I'm attempting to show is that the connected alignment will even follow a complicated curving pattern where they exist. Oh, there we go. X out of some things, do a quick regen. And I can see as I scroll through just some endpoint snaps, I've got a curve break right here, and I've got another curve break right over here. So really the dynamic tracking potential of these connected alignments and the offset alignments is pretty high. So the point with all of this is we spend a lot of time and effort getting our primary parent data correct. And then from there, we just set up some connections and let them do that automatic work for us. No more stack of Post-it notes with random values on the side of your desk because you had to write something down and then go back and modify that data later. No more having to recreate COGO points and reproject them and remodify your profile every time your parent or your offset alignment changes. Now, I do know some folks have run into trouble using offset alignments and profiles around curves and whatever else. I'm not saying this works everywhere, but it works a dang lot of the time and can be really helpful for the situations that this stuff does work in. That's it for today inside connected alignments. So let's go ahead and wrap up this presentation. So what did we learn today? Well, if you missed it last time, we went over the review of offset alignments and profiles, but offset and connected alignments and profiles allow for multiple levels of dynamic interaction. This will save you time, and more importantly, it will save you the potential for error. Did you go back and update every single piece of data of your model? Or did you know that the computer was going to handle that for you? When we're using these offset and connected alignments and profiles, we're doing so because they're key to designing and modeling intersections using corridors. Until the connected alignment function came out, manually assembling your own corridor baselines for these curb returns was a real chore, as we saw toward the beginning of this one. And then lastly, our connected alignments, but particularly our connected profiles, allow for that independent profile design between our dynamic connection points. This means we can go through and make sure we have good ADA access designs, and we can also go through and be really specific with our stormwater collection and our rejection, throw some pipe networks up there too to go ahead and do some pipe network design. And so if you tune in next time, again, that webinar is TBD for the third part of this one, but we'll show you how to take all of this information together and then create your own intersections, as well as how to use the intersection tool for the methodology that it was built for, explain some of its pros and cons. If you haven't guessed already, I generally prefer to do them with minimal interference from the intersection design tool, but we'll go over all that next time and make sure you get the info you need to make your own decision. And also want to just say one more time, thank you so much for your time today, and be well out there.